So here's number 40 on page 757. So we're going to go through this. What is the A here? What is the equivalent resistance of this circuit? So here we've got these two are in parallel. So our parallel resistance equation, 1 over R equivalent equals 1 over R plus 1 over R. In this case it's 2, 3, and 2, so equals 1 over 3 plus 1 over 2, which equals 0.333 and 0.5, which would be equal to 0.8333. So R equivalent would be equal to 1 over 0.8333. So running through this, turn that on. 3 invert 0.5 plus invert is equal to 1.2 ohms for this path here, and that will be in series with this one of 4.5. So 4.5 plus 1.2 equals 5.7 ohms. So that would be the answer for A. Then B, what is the total current in this circuit? So I guess I'll draw this up here, V, I, and R. And they want current, I equal V over R, which is equal to, the voltage is 9 volts, and R is 5.7 ohms. So 5.7, that would be equal to 1.579 amps. That's probably too many digits. I have a tendency to do that. What is the current in each bulb? Well, we calculated the total current of the equivalent resistance, so we know that 1.579 amps goes through bulb number 1. Okay, so R1 equal 1.579 amps. That would be I sub R1. I sub R2 here, that's this bulb. We will need to find the voltage across this in order to do that. So there's a couple ways to do that. Probably the easiest way is, let me redraw the circuit. I should have redrawn this to begin with. So let's take our 9-volt battery, that's this one, come up here, and this is 4.5 ohms, and then these two here, we put those in parallel with this equation up here, and those are equivalent to 1.2 ohms. So kind of backing up in this problem a little bit. So there's the equivalent circuit, and again we have 1.579 going around this loop. So we can figure out what it is for the voltage across this resistor. And again, we're looking for voltage, so covering up the V, that's IR. So V equals IR. In this case, we know I, 1.579 amps. And the resistance of these two paralleled is 1.2 ohms. So 1.2 multiply is equal to 1.89 volts. So we know that we have 1.89 volts across here. And then what was our question again? The current in each bulb. Well, that same voltage is up here, 1.89. This is equivalent to that, so this voltage is across here. So now the I of R2, going back to our circle there, I equal V over R, and the V is what's across this bulb, which would be 1.89, and R of R2, there's R2 to this bulb, 3 ohms. So there's our 1.89, 3 divide is equal to 0.631 amps. So continuing, that's I of R1, I of R2, I of R3. Again, having trouble with lead here. Equals V over R. V is 1.89 and R3 is 2 ohms. So let's see. So there's our 1.89 in the calculator, and 2 divide equals 0.947 amps. And so they ask, what is the potential difference across each bulb? Well, we know for this one and this one, it's 1.89. We haven't figured out this one yet. But this one, we know the current through it, and we know its resistance. So we could, moving up a little bit here. So the voltage across this bulb, we're looking for V, that's IR. So V of R1 equals IR, which equals 1.57 amps times the resistance of the bulb. We're looking for R1 here, 4.5. So 1.579, 4.5 multiply 7.1 volts. So if we would have 7.1, I'm having trouble with lead these days, 7.1, all right, volts of drop here. And this would be from plus to minus because the current goes through it, and that loses voltage as it goes through it. This one here would be 1.89 plus to minus, and then through the battery it increases through a battery because it provides energy instead of. So if we look at it going around this loop, this, if we rounded this to 1.9 plus 7.1 would add up to 9 volts. Well, that makes sense. Let's do another sanity check. This one has a little lower resistance. It would have a little more current going through it. So number 3, it's got almost an amp. This other one here is about 2/3 of an amp. Yeah, that makes sense. This one's less than this one. And then the other sanity check that we can do is do the currents all add up. So if I look, we have 0.631 in our 2 here. So we got 0.631 coming down this way. We got 947 coming around from this bulb. So if we take add those two together, 0.947 and 0.631, adding them together is 1.578. Where have we seen that number before? Oh, that adds up to the total coming out of the battery. So you can check your work this way, and if you've made a simple calculator error, why, you probably won't make it the same way for both of these, and so you can double check your work that way.